Hey guys, welcome back. We've done a whole heap of work with our quadratics and sketching our quadratics from the equation, especially looking at different quadratics in different forms, okay? So we've had our general form, we've had our factorized form, our vertex form, etc. But now we're going to actually go the other way. We're going to be given the graph and we're going to find the equation of our quadratic from the information on the graph. So this is possible if we are given sufficient information on the graph, okay? So I'm going to go through a couple of examples of graphs and what they look like and what form to put them into, given what information we have on the graph, okay? So our first example is a nice simple quadratic that looks like this. So we've got x-intercepts of -2 and 3, and we have a y-intercept of -2. So first of all, we identify our x-intercepts as -2 and 3, and then we're actually going to use the reverse null factor law. So when we are dealing with quadratic equations and we want to find the zeros, when we have a equation in factorized form, remember we use that null factor law to find our roots. Well, we're just going to do the opposite of that, okay? But what we need to include this a in here because it could be any coefficient multiplied by the two terms we found by the reverse null factor, all right? So y equals a, this coefficient we don't know yet, multiplied by x plus 2. So remember the null factor law, we changed this sign because we've solved that linear equation. Now we're reversing it back, and same thing with our x take away 3 term. Please note that the graph is concave up, so a has to be greater than 0. And we're going to use this as a little check because if we get through the next bit of working out and we find that a is actually less than 0, then we know we've gone somewhere wrong because then our graph would look like a concave down quadratic. And that's not actually what we want. So that's just going to be a little check that we're going to have tucked away, ready to go if we need it, all right? So to find a, we need another piece of information. So this is where we look at our y-intercept. So that gives us the point 0, -2. If we substitute in 0, -2, a will be our only variable left, and we can solve for it. So y is -2, so we replace y with -2. Replacing the two x's with 0 leaves 2 in the first term and -3 in the second term. 2 times -3 is -6. So we've got -2 equals -6a, and we're just going to divide through by -6. All right. Coming out, we finish with a equals 1/3, and we just throw that straight back into our equation. And this here is our equation of the quadratic that is graphed above. Okay, so it's as simple as that. The next version of this you might see is when our quadratic touches the x-axis, okay? So we first identify where it touches the x-axis, and then we also identify that y-intercept as well. They're our two key pieces of information. So graph touches x-axis at x equals -4. We've made that pretty clear here. So we're putting this into our vertex form, okay? So y equals a, because we remember we don't know exactly the coefficient. And then we put in x, the opposite sign of our root or our 0, x plus 4 all squared. So remember we've got that repeated root. Noting that the graph is concave down, so remember a has to be less than 0. So again, that could be our little mental check that we do at the end of our calculations. This is where we pull in our y-intercept. So when x equals 0, y equals -12. Therefore, -12 equals a multiplied by 4 all squared, all right? Therefore, a equals -12 on 16, which equals -3 on 4. And there's our check, okay? A is less than 0, so that is all good. And we just throw that out the front of our quadratic, and this is the equation of our quadratic that was graphed above. The last example I want to go through is when you're only given one x-intercept, but you are given the axis of symmetry. All right, so we've got an x-intercept of -3. Our axis of symmetry equation is x equals -1, and our y-intercept is -3 as well. So remember some properties of our axis of symmetry. So the axis of symmetry is the midpoint between the two x-intercepts, okay? So that means the step from -3 to -1, all right? So from here to here, so that's 2 unit difference. So -3 to -1 is 2 units. That distance has to be the same from the axis of symmetry to the next intercept, okay? So therefore, the other x-intercept is at +1, because -1 plus 2 units is 1. So now that we have our two x-intercepts, -3 and 1, we can use that reverse null factor law, okay? So as one is -3, that becomes +3, and the other is 1, so that becomes x take 1. Again, putting our a out the front because we don't know exactly what quadratic it is. Our quadratic is concave up, so a has to be greater than 0. Now we just repeat the steps, use our y-intercept when x equals 0, y equals -3, substitute those values in, solving for a, and you'll find a equals 1. Therefore, our quadratic is just the two terms y equals x plus 3 multiplied by x take away 1. All right, if you guys are all happy with that, if you are following along with the Hazy textbook, chapter 2E, and have a crack at the following questions. So question 1, 2, 3, odds for all of them. Question 4 and question 5 odds as well. All right, we'll see you guys next time.